So what we'll do now is we'll actually jump right into using our tooling. And we'll begin by exploring this code base. So I haven't really said a lot about what's in there. And the reason for that is that we're just going to find this out with Ocular ourselves now. And we'll see two tools. First of all, we'll see Java to CPG. That's a program that takes Java bytecode and converts that Java bytecode into code property graphs. So into our internal intermediate representation that we can then query. We will then see how this code property graph is loaded into Ocular, and we'll then run a bunch of different queries to see how the code can be accessed from the outside world and how it interacts with other components. So you should now see a shell, and what you see here is what you get right after installing the Ocular tooling. And there's that program Java to CPG. And I just said that it's Java to CPG takes in Java bytecode. Now what it takes in is actually a jar, so a Java archive. But Java to CPG in the tradition of Yearn is not too picky about what these Java archives look like. So you don't really need a manifest or anything, or you don't need to put your your class files into any specific order. It's enough if it's essentially a zip file containing class files. And I'm going to demonstrate that now. So I've unpacked this OpenRefine into a directory, OpenRefine 3.1. And OpenRefine actually does not come as an executable jar. So what I'm just going to do is I'm just going to say, find all the class files in there and then zip them all together and call that OpenRefine jar. Right. And so what you see now is we have a zip file called openrefine.jar, and in there you see a bunch of class files, and this is what we're going to be feeding to Java to CPG now. All right. So yeah, not downloads. There we go. So OpenRefine jar is here in this directory now, and Java to CPG receives that jar. And now we can initially tell it about different namespaces that we're interested in. So given that this code base was once at Google, there's one namespace called com Google Refine, in which the OpenRefine code is, and another called org OpenRefine. And we're only going to take this code. And once we run this, we get a code property graph. There we go. So now we have a code property graph. There are a lot of messages coming in. Let me just quickly check. Okay. So I will answer all your questions in the end. I was just checking whether somebody says I can't hear you. That would have been bad, but you can. Okay, that's good. Okay, let me see. Okay, so we have a code property graph now, and it's 15 megabytes, and we can now load this into Ocular. Okay. So this is the interactive Ocular shell. I'll later also show you that you can use this non-interactively. What I'm going to do now is load that CPG, and the CPG is loaded, and we do a bunch of transformations and enhancements on it. This can actually be done just once, but currently in the default settings, these transformations are done every time. All right, so now the CPG is actually loaded, and the next step is we would like to find out a bit about the different types that exist in this program. So we can say something like CPG type decal name, and we will get a complete list of all of the types that are used in Ocular. Right. And now we can start filtering on these. So for example, we could ask with regular expressions, please give me all the types in Java lang. There we go. Yeah, and that will give you different types inside Java lang. And so now one nice feature of this is we can actually differentiate between types that are used by OpenRefine itself and types that are referenced, like outside types. So we can say, please only give me external types, and actually from there go to the namespaces, right? So the packages essentially, and give us the names of those namespaces. We can also ask for this to be distinct and to be sorted. There we go. All right. So this gives us a view of all of the different namespaces used. There's also a nice browse function that you can use to get all of this into a pager. There we go. So now it's inside a pager. And so those are the different packages that are referenced by OpenRefine. Now, going through these, what we see is there is Java util zip in here, and there's also Java X XML stream in here. And so getting that kind of information is pretty useful because many of these libraries are associated with typical kinds of vulnerability patterns for these libraries. And what we'll see in a bit is that we can actually find vulnerabilities associated with these libraries in particular. All right. Now, the next thing we might ask ourselves is this a web application? Is this something that we can access from the outside? And what we can do there is we can just look for types called something HTTP, just as a wild guess, essentially. And I'm just going to say name. There we go. All right. And what we see here is that there's actually a type being used called Httpservletrequest. And well, people who've audited Java applications, Java web applications, know that these are requests that come in via HTTP. And so any data that comes from there is potentially attacker controlled and needs to be handled with greater care. And knowing this now, we can actually ask for all parameters which have an evaluation type of Httpservletrequest. There we go. Oh, HTTP. Oh yeah, I need to use wildcards here because it's actually Java X something Httpservletrequest. There we go. So now we have all of these parameters, and we can now jump from those parameters to the methods that receive these parameters. I'm just going to say full name. There we go. And so now we see a lot of different methods, all of which receive HTTP servlet requests. Now, some of these methods might be calling each other. So the question is, can we maybe even identify those for which we have no callers? So those are the ones that are likely triggered from the outside. And yeah, we actually can. So we can ask method filter call in, and actually I want filter not call in. So that means give me all the methods for which there are no incoming callers. And I can always ask how many are these, and we see those are 115, while if I remove this filter, we have 185. Okay, so we've already reduced this a bit. Okay, now we can go ahead and look at the names of these, list those, and again, make these distinct. And this actually shows us that the OpenRefine codebase follows standard naming conventions for naming of HTTP handlers. So they use the method names doPost and doGet, doPut and doDelete to describe handlers of post, get, put, and delete requests, HTTP requests. And there are a few exceptions to these. So we have the exceptions here, but we see mostly this naming convention holds. Right. Okay, so back to my slides. What did you just see? Well, you saw that we can identify which components the codebase interacts with. And you also saw that we are able to identify the HTTP handlers So the places where attacker-controlled data reaches the application.